Welcome to my wrap up of the 2021 Advent of Code event. Um, uh, Basically, I have reflected on every kind of individual day and puzzle that happened over the course of Advent of Code. But I just wanted to give some reflections on the overall event, what I learned as a general, not from specific puzzles, but from the whole experience of doing the whole thing. Um, and I have to say, the last few days I've been vaguely thinking about that. I haven't come up with anything terribly deep, but I'm not gonna put this off indefinitely. Um, I think it's good to do reflections, even if you don't think you've learned that much. And just brainstorming all the different line items is a good exercise in its own right. So, just to kind of reiterate some background and perspective here, um, I haven't actually been paid to program for more than 5 years. I have done a little bit of programming as part of my job as kind of managing engineering teams and so forth, but I haven't really written any production code lately. And partly that was an incentive for, I guess it was maybe 4 years ago, I did my first advent of code and I missed programming. So that's kind of why I started doing this event. Um, and actually, programming hasn't even been my primary skill for more than a decade now. After I went back and I, did my doctorate in kind of computer sciencey things, and then I was hired as much for kind of management and engineering skills as I was for my ability to actually crank out code. And that kind of keys in on one of the most important things to understand about my rhetoric about advent of code is I think there is a huge difference between engineering and programming. Programming is just putting the code together that gets, that accomplishes the goal you want. Whereas engineering is all the complicated skills about scaling that up, working with other people, being able to maintain your code, and I could go on for indefinitely about what engineering is in a software context. But the important thing is that Advent of Code is not engineering. You don't need any of that engineering stuff because every single Advent of Code problem you can fit in your head, you're doing on your own, it's not going to require any maintenance. And my perspective is that in the industry, it is a huge problem that people get caught up in all the engineering issues and completely lose sight of the fact that you need to solve the problem. And very often, when there is like a 30-line solution, like there's a clear input and a clear output, and there's like a 30-line algorithm to get you from input to output, generating 500 lines of like some class hierarchy and all this other crap going on is not better. But I've seen both people with computer science degrees, and they go into industry and they've learned the difference between you being a professional and just some amateur hacking on his computer is that you write all this crap because it's better, and it's not. I mean, it can be if you have a genuinely complex problem, then absolutely you should apply a lot of these engineering disciplines, but the organizations I've been around I hesitate to call it over-engineering because that implies a level of robustness. There are people who add engineering complexity to simple problems that don't have complexity. And engineering at its best is about managing complexity, not introducing complexity. Anyway, I could talk endlessly about that topic. I have strong thoughts. I have lots of experience that those thoughts are based on. That doesn't mean my opinions are correct, but this is something I have thought a lot about in the last 10 years. And again, thinking a lot about something doesn't mean you're right, but it does mean that you can talk about it. So anyway, that's my perspective. So getting on to this particular 2021 Advent of Code event. So from a computer sciencey perspective, there wasn't a lot of complicated parsing this year. I think the parsing was easier than previous years. I only actually used, because I wrote this nice regular expression interface, because Swift has no regular expression interface. I believe they're working on that. But I only used that once, and it was in day 2, and I didn't even need to use it, really. So, well, I don't know. That's an interesting data point. That the parsing seems to have gotten easier from prior years. In terms of the computer science algorithms and data structures that I employed to solve the problems this year, arrays and sequences, grids, which are really just two-dimensional arrays I used, dictionaries or associative arrays, but like these weren't necessarily sorted things. This is something that's changed a lot just in my, 20, 30 years in the industry. When I was, an undergrad, we were all taught about trees, and it was all about sorted associative arrays, based on balanced binary trees. And the industry has realized that hash tables are better for almost every application. So hash tables are plenty good enough for everything we did in Advent of Code. We used some sets. I did use queues a few times, but I think the main application of queues was in breadth first search, right? And I wrote my own queue because Swift doesn't seem to have one built in. It's notable what kind of computer science-y things I didn't use. There wasn't even a call for linked lists this year. Linked lists are very often something you just build on the fly because it's just one node with a pointer to identical nodes. But in prior years, I remember having to build linked lists, as part of particular problems. Didn't do any of that this year. Didn't use binary search, which again is something that isn't in the Swift standard library and only realized in the last few days. Didn't use it, even though that is like the first algorithm every computer science student learns. I should note, I had this thing such that you could index into... because binary search very often, instead of binary search has a logarithmic complexity. You can just do a linear scan for linear complexity, and if the numbers are small, linear scan isn't just as good. It's very often a lot faster than binary search for small numbers. And that was the case with the things this year. There were a couple of places I could have used binary search, but actually linear scanning was probably faster anyway. I did have this thing that indexed a string by integer position. I believe, I'm not actually entirely sure what underpins Swift strings, but if they're encoded in UTF-8, then technically finding a character does require scanning the whole way and seeing how many bytes each one takes to get to that thing, which is probably why the standard library doesn't include a random access subscript operation for strings. But again, the strings that we used here were of bounded size. No line was more than, 100, 200 characters, and so that's not a terribly big deal. We didn't use heaps, even though I did build a heap and put it in my Advent of Code library. We didn't use any, at least explicitly structured trees of any kind, and particularly we didn't use like the Fibonacci heap, which is a tree-based heap data structure. And Fibonacci heap is kind of the upper limit to complex data structures anyone will actually use, mainly because it's used in shortest path and A-star search and things like that. But as a rule, nothing below this line will ever be necessary for Advent of Code. We didn't use skip lists, even though they're very interesting data structures. We didn't use binary decision diagrams, which are sound very niche, but Donald Knuth at least seems to believe they are as fundamental as anything else on this list. So he's allowed to have opinions, right? But we also didn't even need a true shortest path algorithm. A lot of people will use true shortest path algorithms in Advent of Code. There has never been an Advent of Code problem that requires a true shortest path algorithm. Breadth first search is enough. And in fact, this year, I very stupidly did end up doing a true shortest path algorithm, and then I thought it through and realized, no, there's a simple way to transform the problem into something that breadth first search can tackle. So, I find this interesting because if you were to, take a student just learning, to program, technically they don't need to know very many computer sciencey concepts. The computer science concepts, these are probably taught at high school, everything that we use for Advent of Code. But, the things that we didn't need, having some experience with them, going through the formal undergrad education of learning how to, and the stupid thing about how do you reverse a linked list, which is the classic bad interview question. Even if these aren't useful in their own right, I do think having gone through that definitely helps you think through any kind of somewhat novel algorithm. And Advent of Code is about mildly novel situation-specific algorithms. And so the fact that computer science education does hit a lot of these things, on the did not need list, doesn't mean that it's wasted time, right? I think it's good mental exercise to learn about all these data structures. But anyway, so now let's move on to the actual engineering-y things. So I use Swift, which is a finely typed language, strongly typed language. People use different terms. It has types. I only really use type checking by shape. And by that I mean by default I used a lot of tuples and arrays and dictionaries, right? The point is I didn't assign new types to those shapes of data structures. If you were to create an array of ints, you could say it's not just an array of ints, it's an array of lengths, and you can do that by wrapping it in a struct. And that allows you to do harder type checking because someone else with a different array of ints with a different semantic meaning could come along and what if you confused those two? In all these cases here, that wasn't a problem, and so merely type checking by the shape of the data was good enough. I never introduced a struct for the sake of, adding additional type checking. There was very little object-oriented programming in made code. In fact, I did use a range dict on day 22, and also on day 18, I came up with a few variant implementations just to kind of toy around and learn a little more Swift and everything. And one of my implementations did actually use inheritance, which wasn't nearly as bad as I thought. Not because I think inheritance is complicated, it's because generally I'm quite biased against object-oriented programming because I think inheritance in particular is hugely overused in industry. And I was expecting, and it tends to make your code quite messy and more of a maintenance problem when you have an option of not using inheritance. It sounds like I'm making blanket statements that inheritance is bad, and that's not really what I mean. But regardless, I could solve all these things without using inheritance, so that's an observation, right? I did use generics. The one place I used generics several times was because Swift is so annoying about strings. It has multiple different types of string types. It has string and it has subsequent, which is when you get a substring. And there's a reason that Swift does this because the idea is you don't want to keep copying memory for strings all over the place. So they point at similar memory. And the thing is, in Swift, these don't even inherit from the same type. They merely conform to the same protocol. And you can't write code that takes, parameters that conform to a protocol, but you can write a generic that takes a type that conforms to a protocol, if that makes any sense. And so I did use generics just for the sake of writing a couple of functions that can take anything stringy. You need generics to do that in Swift. And also, I did use generics to write this range dict thing for day 22, which I quite like as this little data structure that I built. And I did actually use the genericity of that because, it wasn't just that I wrote this to be general purpose. I really did pass several different types of T into this thing. In particular, I think I ended up with a range dict of range dicts of range dicts of bools, right? So I did actually make use of this generic, the ability to string generics together in that way. So again, that's just an interesting observation about what, kind of engineering-y features I made use of. If we ignore my silly foray into shortest pass algorithms and Fibonacci heaps, because I did come up with a simpler approach. So my longest solutions were, 150 lines of code or so. And this is actually counting comments. And in some cases, I commented out huge amounts of code. On day 24, I had 144 lines of code, but I commented out 150. So it was really a 30-line solution. But I'm not going to feed my code through something that counts non-white space lines or something. Line counts are not terribly indicative of code complexity. No. Line counts aren't the last word on code complexity, but they do give you some indication of how much logic exists in a place. And so I averaged, just under 70, and that's including all these comments and everything. And the median was about 60. So half of the solutions that I wrote had fewer than 60 lines in them. And I guess the important number, 150 lines, these are things that I would say most any programmer can fit 150 lines of logic in their head. And that is quite an important metric. Engineering is mostly about what you do when you can't fit an entire problem in your head. Once you've written more than really just 50 or 60 lines of code, then you start breaking up into functions. You start caring about the APIs to those functions and so forth. And obviously I did write several functions, particularly in these larger things. I definitely did have a few functions to break it up into smaller pieces. But it never got so big that it really needed to be enormous. Most of the time when I was using functions, it was because you need a function to make something recursive. It was more for the control flow properties of functions than for the engineering-y aspect. I think that's even true of my range dict and everything. The object orientation was more about me managing control flow and instantiating on multiple types and that kind of thing. What else did I say? Okay, so those are my line counts. So I did all these 25 days in Swift, Apple's language, largely used for programming the Mac and iOS and so forth. What do I think about Swift? Because I've been programming Swift for a few years now, and I do some iOS programming and so forth, but actual programming for platforms, you spend most of your time worried about the frameworks that you're using. And actually doing interesting algorithms is relatively rare in practice, in my experience. So, what did I think about Swift? Tuples are very half-assed. I've said that at least a half dozen times throughout these videos. It really annoys me that they are so half-assed in Swift. I hope that the language group is working on improving that, right? Strings and string protocol. Strings are also quite annoying to work with in Swift because of these things that I already mentioned. And I don't know whether it's worth Swift trying to improve that. There are reasons that they're annoying to work with in Swift. And the annoyingness is quite easy to work around. It's just in this context where you want to do something quick and dirty and don't care at all about efficiency and just want fewer characters on the screen. Then this distinction between string and subsequence and string protocol gets on your nerves. In any other scenario, it's pretty easy to work around. So I don't think that's a problem with the language. It just makes it a little more cumbersome for certain kinds of string processing. I The string split function, this excluding empty subsequences, I didn't even copy the name down correctly. I still think that's super weird. That's not the way other languages code split. So I question the choice of the standard library designers to make the default to throw away empty subsequences. And I still forget just how much in Swift by default gets copied. And that, again, it's not like I really forget. It's just, in careless, quick programming, I often don't realize, I'm iterating over a thing. I made a whole copy of that thing. Or when I'd get something out of a dictionary, actually, the semantics of that, when I was first learning Swift, I wrote a few tests. When you get something out of a dictionary, when you assign... No, hold on. If you access a dictionary and then call a mutating function, what it does is it calls get and copies the thing out of the dictionary, calls the mutating function on the copy, and then calls set with the mutated copy, which is all... it's all very Swifty. You have to get used to that's what's going on under the hood. And if you forget that, because it feels like you're modifying the thing in place, but you're not. So, anyway. Okay, so I wrote this little library, and I had, before I started this, I thought my challenge for this year would be building out this library of useful functions to make Swift a better platform for coding in advent of code. In fact, that largely went by the wayside. I made a couple of updates kind of early on in this thing. I think I added my digit grid stuff. But otherwise, I didn't make all that many additions to the library because making the videos became like my project for the year. But reflecting on that library, so I had a file, I have one thing in there which mimics a lot of the Python string functions, different versions of split I used heavily, and a bunch of other Pythonic string functions. Those were super useful. By far the most useful part of the library was those Python string functions because Swift has relatively poor string searching, scanning, editing functionality built into the standard library. So I like my little Pythonic string function additions, right? I also had a couple of routines that would just read these input files. One just, read all the lines into a big array. In truth, that's already a one-liner in Swift, so that's not a big advantage. Reading by records, meaning I read, an array until I hit a blank line, and then I read another array until I hit another blank line, and then I get a two-dimensional array. I use that on at least one, maybe a couple of problems, and that actually is not hard code, but non-trivial and uninteresting code. So I'm glad I had that in a library. So I think that was a success, having that available as well. That said, all of my clever string things, and I had this thing where I could index a string by position, as I mentioned before, and that's quite a serious abuse of the language for reasons I've already mentioned. But maybe the thing is, in Swift, all the string stuff is based on it's a fairly compact memory representation of strings. I think it's using UTF-8 under the hood. If you just turn, and the reason I want to be able to index by position is because very often I'm using these strings as like a grid. So I have an array of strings and I'm using them as a two-dimensional grid of characters effectively. Maybe I should have just translated into characters. And again, I don't know exactly what Swift is doing under the hood, but I wouldn't be surprised if a character were a 32-bit type, because I think every Unicode thing can be represented in 32 bits. So it's, 4 times as big as a string, but for this stuff, it doesn't matter at all that you're wasting all that space. So maybe I should have just, my input routine should have just turned it into grids of characters, and maybe I should have made arrays of characters conform to string protocol. Actually, for all I know, arrays of characters already do conform to string protocol. Maybe that's in the standard library, and I've just never looked. It would be slightly weird, but useful. So, so I can see the arguments for and against doing that, but I can definitely see the arguments for making array of character conform to string protocol for the purpose of advent of code, if you ask for it, right? So maybe that's something to think about in the future. I wrote a queue, a simple node-based queue, and that was useful, but node-based queues are actually the wrong implementation from an engineering perspective. It's incredibly slow. When I say incredibly slow, it's probably 1 or 2 orders of magnitude slower than a queue based on an array, which is implementable as well. I made heavy use of DEX in C++, double-ended queues in C++, which are array-based. I was thinking it might be an interesting exercise to go through the Swift standard library implementation of array, which I have peeked at before, and maybe made a version of that is a double-ended queue, because I think I would learn a lot from that exercise about the underlying language, because the standard library designers have really thought a lot about efficiency and even code style and everything. There's something to learn from the best, most fundamental code in the library. So that might be an exercise to do for me at some point. I did add these grid functions, so I had point2 in there, and I could access a 2-dimensional grid by point2 as a subscript operation. These were vaguely useful convenience functions, but I grant that they were incredibly half-assed. So whether I think them through more fully and then maybe offer 2, 3, 4 dimensional grid functions for next year in this library, that's also something to think about. Yeah, and as I said, I didn't really extend this library very much after the start of the event because I was focused on these videos instead. And each year now when I do Advent of Code, I like to kind of set myself a new little challenge to make it a little more interesting. I thought this library was going to be it, but I lost interest. In terms of the tool chain that I used, so I was using BBEdit and a shell. And part of the reason I chose that is because I liked the idea of part of Advent of Code and using Swift for Advent of Code is kind of proving the point that Swift doesn't have to be just a language for interacting with Apple frameworks and Apple tool chains and so forth. I do think Swift has a moderately rich life on Linux. I'm happen to be running on the Mac because I think the Mac is the best desktop platform. Anyway, so that's partly why I chose. I was editing in BBEdit, and I was using the shell. And for reasons I explained in prior videos, I normally, like in prior years, I was editing in Vim because I'm much faster at using Vim. But a lot of the work I do these days is in Xcode, and so I kind of am trying to get myself more efficient at using non-Vim text editors. So I kind of set myself a challenge of using a Mac-centric text editor, but not Xcode. And so I use BBEdit, which has a problem with commenting in and out lines. It changes the indentation. But other than that, BBEdit was fine. It's a very good text editor, and it's like the most Mac-y text editor there is. So that was good. I tried to run it in LLDB because I actually do have a fair amount of experience with command line debuggers, and I think they're generally very good. But it didn't work very well for me trying to debug. I don't think I was ever successful getting any useful information out of the debugger this year and the few times I used it. The reality is, if you want to debug or profile or any of the other more high-level kind of developer activities for Swift, you should just do it in Xcode. The tooling in Xcode is very good for all these things. So maybe in future years I will use Xcode, mainly to have access to debugger and everything. The trouble with Xcode, it is quite heavyweight, and it's not really set up for running kind of command line utilities and trivial one-line files and everything. And as I say, it's part of what I like about Advent of Code. It forces you to think just in terms of programming and shove all that engineering stuff to the side. Xcode, has really strong support for all the engineering-y stuff, right? So it could be a bit of a distraction if you're trying to like make a conscious effort to do as little engineering as possible, which is the kind of mindset that I use to do Advent of Code. Anyway, so let's talk about making these videos, because this was entirely new to me. I didn't even have a YouTube account. Oh, the dog seems excited. Didn't even have a YouTube account before, the first or second week of December. I had never live streamed or anything. I started by just recording my screen and putting like a QuickTime player mirroring the camera in the lower right corner. I have recorded all these things using the new, 2021 MacBook Pro built-in camera and microphone. And I don't have very discerning tastes for video and audio quality, but I have thought they've been perfectly acceptable. I'm very open to comments that they're not good enough, because using... Bailey! Hey! Sorry, the dog is excited about something. Possibly a bear. No, the bears are probably asleep. Possibly a deer. Okay. So, a more robust setup would probably use the iPhone's reader camera, which is a very high quality camera. And I do have an external USB microphone that I could use. I didn't use any of that crap. I'm just recording straight off the laptop in the most bare bones setup that you can get. And I still thought the quality was, pretty reasonable. After the first week, I moved to using this OBS, which is an open source project for screen recording and live streaming and all that. And I have mixed feelings about OBS. On the whole, it's a very good tool. It does all these things. It makes, streaming to YouTube and I assume to Twitch and whatever other services very straightforward. You don't need any kind of technical understanding of what's going on. I did have to go in and do a bunch of tweaking to the default settings because I wanted to record my screen at full resolution, because all the text got fuzzy if I downscaled it initially before uploading it to YouTube. So after a few tests, I got it to record my main screen at full resolution, and that seemed to be okay. But the user interface for OBS, I don't want to rag on open source in general. Open source does a lot of great things and has made the world a great place, but open source user interfaces are open source user interfaces. And if I need to explain that anymore, I will never convince you. I swear to God, there is still this window. How do I get out of full screen? Hold on. OBS still has this window. You see this window right here? I can't get rid of. It asks me, do you want me to check for updates? And there's no way to eliminate this window. This is the kind of issue that any non-open source project would be so humiliated by, it would be fixed immediately. And but open source tools kind of consistently have just these incredibly embarrassing bugs. And within the the OBS thing itself, you can dock panels, so you can have this heads-up display of all the things going on. You can dock them any way you want. But on the other hand, the actual consistency of how do I change the resolution of this or that, it's split between preference panes and multiple settings and everything. It's exactly what I expect from an open source user interface. And if the open source people out there are really offended by this, then make better UIs. I don't know what to tell you. It's not just an opinion. Open source UIs almost always suck. Maybe not in all cases, but this is my expectation when I download an open source tool. It is infinitely flexible because people can't make the decisions, and it ends up just a big mass of features that everyone kind of shrugs their shoulders at. Okay, enough rank on open source. I'm sorry. You guys are great. You're terrific. Thank you. And I got this tool for free. I can't really complain about it, but it does have problems. It really does. So, anyway, what else about these videos? I was very nervous being on camera, at least for the first week, maybe two, and I think that hugely slowed me down. I think I'm more comfortable on camera now. I don't know whether I at this point I think it's the matter of trying to talk while I'm programming still really interrupts my flow. Like just sitting and thinking and that's seems a lot more efficient than trying to like gab as I'm typing and thinking. And also, like traditionally when I'm programming, there's this thing, sometimes your fingers can go and you're typing and you're thinking at the same time. So you just have, and you can kind of switch between the two. But when you're trying to talk, like, I don't know, everything is all thrown off. So, and maybe more experience will make me better at that, but I can't imagine I'll be doing a lot of programming on camera. But I still think this experience has helped me a lot, at least understand what the challenges are in doing that. And I kind of respect, these YouTubers who are like playing games and gabbing at the same time. I think that's probably less thought intensive, but even so, they have certain skills that I now appreciate a little bit more than I did. And that was the goal of doing these videos, is trying to understand what are these live streamers and gamers and everything. What are they doing? I think I understand a little better. Anyway. I do, in some of the later videos, I made more of an effort to explain what I was doing, but that's partly a property of they are more complicated problems. The first, week of problems are so trivial. What is there to say about them, right? I mean, it says in the problem description what you got to do, and then I'm just doing it. Like, what am I going to say, right? Whereas the later ones, there were a bunch of different algorithmic approaches, so I could talk about that at length. You can see I can talk about so many things. In the first week it was trivial. The second week I talked a lot about code structure, and then the third week I started talking about algorithms and design and representations, and the fourth week I complained about how tired I was. So I can talk. Okay. The big downside to making the videos was that I watched them back. I mean, generally, this is after I posted them publicly, so if I did something horribly embarrassing, it's already out there for the world. But I made the videos partly because I'm my main viewer for this stuff, and reflecting, really helped me learn a lot more from doing the Advent of Code event. But the reflections were largely based on watching myself go through it the day after I did it. And, if I were to watch in real time, that's twice the amount of time, which is fine in the early days when it's 10, 15 minutes to solve the problems. But when I'm taking, some of these later ones, I took 3 hours, to do it. And then I have to watch 3 hours back. I mean, in truth, I was watching these things at double speed, which makes me look much smarter and quicker. So I recommend everyone watch these videos at double speed. But, what was already a bit of a burden doing Advent of Code, particularly at the end of the month, became quite problematic when I was spending so much of my day, just thinking about it, really. Because watching and then doing reflection, writing the reflections usually I do in time as I'm watching the videos, but even so it takes some time. And even just uploading the videos, once I'm done, I can't just go straight to bed. I have to do it and make sure it all gets uploaded, because a couple of times it aborted in the middle for whatever reason, and So it's time consuming. It's a little bit of work. Even my completely bare bones setup while I'm doing live streams and no editing and everything, it's a little bit of work. I'm curious whether professional YouTubers do air checks, whether they're watching all of their videos, or whether at a certain point it's not worth their time, because I think YouTubers put out a huge amount of content. TikTokers probably, because they only put out a few seconds, I assume they watch it over again, but there are people streaming for hours and hours on end every day, right? Anyway. So moving on to my competitive performance, I can actually bring up, oh no, that's the wrong window. What do I have? So we can bring up my terrible scores from this year. I mean, just in terms of places, I did a lot worse this year than any prior year that I've done in real time. Because generally I was around the 500 mark almost every day in prior years. And this year, I only got, so what did I say? I said So my best finish, I managed place 110, which is a shame because my goal was just to hit the leaderboard once. That's all I really wanted. But only 5 days in the top 500, which is, you know, I don't know how much of that is me trying to do these videos and everything. How much I probably am getting rustier at programming. So that's, I'm not going to pretend that's not a factor. But also, I do think more people are doing Advent of Code every year, and I think they're getting better at it. Like, programming competitions are a big thing these days, and it's a distinct skill from engineering, as I've said, but just cranking these things out so quickly. The people who make the leaderboard, like, every day, it's amazing. And I have seen the code and, like, videos from some people who make the leaderboard. They're very often people who are, like, code golfers, meaning, like, can you write a program to do such and such a thing in the fewest number of characters? And, like, that's crazy. Yeah, I can understand it being very intellectually engaging, but, like, I say there's a distinction between programming and engineering. The connection between code golf and engineering is just so tenuous that I'm lost. But it looks like fun, but it's not something I've ever engaged in. As I said, my nerves were a factor, at least in the first week. After that, I can't really blame it on nerves. It's, just I'm not particularly quick. In most years, the back half of the competition is where I get much more competitive because it requires a little bit more thinking. This year, the last week was atrocious for me because or at least the last 4 days, because I was tired and burnt out. I mean, there's probably a lesson about general, engineering. Like, if you're a professional programmer, because I have run a bunch of teams, I would occasionally see people who were in the office late multiple days in a row, and I would have a talk with them about, like, that's not a good way to work. If you're working long hours, 1 or 2 days sometimes is actually super energizing and fun and everything. But, like, if you start doing that consistently, it doesn't save you any time. You get dumber. I mean, you really, really get dumber. And, they talk about a 10x programmer and everything, which is all kind of nonsense, but it's definitely the case that it's easy to make yourself dumb enough to waste way more time than you're saving with these extra hours. It's a thing. Anyway, so I did, and this year again, I did better in the second half and then faded as I, didn't have any energy left. So, overall, I did enjoy this year's competition. I don't want to pretend that, like, it wasn't fun. Even the last few days were fun. Getting the finish line is fun. But I've always noticed from the first competition I did, which I don't think I did very much in real time the first year I did it, I would do the morning after. I'd come into work at, 8:30 or something like that, and I'd do last night's Advent of Code, and doing it in the morning, like, I am much more on my game. It's more fun. And I think I mentioned this at the end of this little overall list. There's this concept that I think I first encountered in maybe the Pragmatic Programmer or something, of a code kata. And a kata is like, martial artists just do these like little dances, these forms that they do. And the idea of a code kata is just you write some very simple little algorithm or piece of code to get yourself warmed up and ready to do your real programming for the day. And when I do these Advent of Code things in the morning, like, it is a good introduction to my day. When I do them at night, I always kind of dread them, and it's hard, and I don't. So every year I get to the end and I say, next year I'm not going to try and do them when they're released. I'm going to do them the following morning because it's more fun for me. And yet every year I go back and say, no, but it's fun to try to make the leaderboard. So, I don't know. I do think 25 days straight is a lot. I realize it's Advent of Code. It's an Advent calendar, but it's not the same as just treating yourself to a little chocolate. I do think, like, if there were, as big and popular an event that was just like 1 week, maybe 2 or 3 times a year, I think that would probably be a better format. But like, I'm not criticizing Eric for what he's done here. This Advent of Code thing, just the sheer number of people who participate is really, I find it inspiring. And so I'm not dissing the event in general. For me, at least, though, 25 days in a row, not skipping any of them is exhausting. Doing anything 25 days in a row, just knowing that you're going to have your butt in the chair with no days off, even if it's easy, like having this thing on your schedule every single day, I don't know, it kind of wears me down. So, anyway. I did get to use more of the Swift language. Like, I used enumerations and recursive enumerations, and this one day I implemented something a bunch of different ways because it's a fairly well-kept secret that most programmers use a tiny profile of the language that they are ostensibly expert in. You don't need very many programming features to solve almost any problem. In most cases, you're forced to use the dark corners of the language because the libraries require you to use those dark corners of the language. And many of language features are there specifically for library designers. I mean, I guess I didn't even mention this in talking about Swift, but obviously I didn't use protection levels or any of that crap. In fact, I screwed up some protection levels. I didn't make things public in my little library, so I couldn't access them. But anyway, it is nice to have something that forces, or at least gives you an opportunity to play around with a bunch of the features of the language that you don't use very often. I don't even use break and continue statements in real life all that often. For good reasons, because a lot of people think that break and continue are the modern go-to and should be generally avoided, and they're a sign that your code structure is a little bit funky and maybe you should factor it into, like functions. And maybe functions with multiple returns is better than loops with breaks and continues in them. And very often you can choose between those things. But I do think it's educational to kind of go out of your way and try and use more features of the language, like these recursive enumerations and things like that, which I don't think I've ever used in anger. So that was educational. It's one of the reasons it's worth doing Advent of Code, right? What else did I say here? This year, more than any other year, there were I had bad approaches to a bunch of these things, mainly in the last week, but there was one earlier one where I did this Fibonacci heap thing where I didn't come up with the right approach. And I think I mentioned this in my last video, just talking about the last few days. That is quite humbling because just in terms of self-image, that's, coming up with good algorithmic approaches to problems is something that I think of myself as very good at. And it's important to remember that there's always, I could be a lot better at it, right? These weren't hard problems, and still I went down the wrong path several times. Some, how much was it being tired? I can't just blame it on being tired. Like, I did the wrong thing. And so it's useful to remember that, like, in reality, I can choose poor designs. I'm capable of that. So you should always be skeptical, even of your own choices. So, anyway. So what did I come up with? Action items for the future. So if I do Advent of Code, I will almost certainly do next year's Advent of Code problems at some point, right? I should probably use Xcode next time. I mean, this whole thing about making a point of using the command line because you could do the same as I'm using on any platform and everything, whatever. So maybe I should use Xcode. That does require kind of setting up a project in Xcode and thinking through your structure for where the files will go and everything, because just my simple thing here of write one Swift file, that reads the input file and then spits it out to Xcode isn't really set up for that. So I will need some kind of structure, some more engineering-y structure. I know there are other people who they set up every problem as a unit test, and again, that strikes me as like super weird, but okay, yeah, it works for them. I'll think through how I would set up an Xcode project for doing this next time. In terms of the video, it's somewhat unlikely. Well, no, I won't say that. If you want me to make videos of any kind, for next year's Advent, please leave a comment. Right now, I'm leaning towards, I think I learned what I could from doing the videos this year. But if you would like me to make videos, then absolutely leave a comment, because that will make a substantial difference between me not doing videos and doing videos. I don't promise I will make videos, but like, if a dozen people say, oh no, I really enjoy them, then that's, maybe it's worth it. The really nice thing to do, now that I know how to record a video and post it, the next step is to actually learn to edit videos, which is not something I know how to do right now. I mean, I'm sure it's just as learnable as live streaming or any of this other stuff that was pretty trivial. I spent, an hour and I knew how to do all this. But really the right thing to do would be to start off, give a live stream, and then, like, I assume you can have chapter markers, and then have a walkthrough, just like a 5-minute, here's, what the problem was really asking for. Here is the approach I took. Here is how it manifested in code, right? And then, edit on a final chapter recorded the next day, which is my reflections on those things. Those should all really be one video. And that would also allow people to get, like, the main thing that people seem to be looking for in these videos is, okay, I had trouble with, doing such and such a day's problem. Can someone just walk me through their thinking through this thing? Watching a live stream is actually quite a poor format for that. But like a 5-minute explanation of here's how I thought about the problem, here's my approach, and you can stop at any point and think, oh, that's what I wasn't thinking right. I think that would have some value, so you could skip ahead to whatever chapter you were interested in. Again, I'm skeptical I'm going to put the time into doing that, because already, just watching my videos and doing the reflections was a pretty big time commitment. But I think that's probably, beyond just live streaming, which is what it is, that's probably the kind of video that I should have been putting together for all these things. Oh, and also I mentioned here that whole thing about explaining how you understood the problem and your approach and how it manifested in code. That is actually a useful professional skill. That's what you're doing in industry quite a bit, right? And so developing those communication skills, I think, is useful for everyone, and we can all improve at it. So I do think that is a useful exercise. Other action items. I do occasionally scratch down notes, like it's part of my general process that I always have a notepad, a .grid notepad, available, and I think on paper quite a bit. I could think on an iPad just as well, and if I could get that iPad projected on the screen, that would be useful in sharing how I'm thinking about this stuff. And I assume that's fairly trivial if you take an hour to figure out how to do it. So that might be something I could puzzle out. Again, I don't know if I'm going to be making these videos, so it might not matter, but it's a thing to consider. And finally, something that I might actually do before next year, this library, reading your inputs, that's the main thing that the library is about. And even, I said all the string functions were useful because, kind of splitting strings and slicing and dicing them is just part of input processing. The right thing to do is really go through all 25 inputs and then come up with better APIs. What kind of API in a library would have made it easiest to process all these inputs. And I've had quite sophisticated thoughts. I've had thoughts about rather complex library functionality that could help a lot with that. And but the stumbling block for me was, I had this thought that I would like to just give it some text and then say, and I would like some structure that looks like this as the output. Give an input line and say, and I want 4 numbers structured into 2 tuples with these labels or whatever thing. and you pass it in, and it generates a function that reads a bunch of lines and generates structures of the same shape. And the way it would do that, it would introspect the structure and see, oh, that's an int, so I know it has to come from something with an optional negative sign and then digits and yada, and it matches those to the string. The trouble is that introspection of the shape, I know how to do that in C++. In Swift, I mean, it was a fairly interesting exercise, but eventually I gave up because I had other things to do. In Swift, kind of generics don't interact with introspecting shapes at all in the same way that C++ does. And there are some weird inconsistencies, particularly around tuples, that make it at least obscure. I couldn't quite figure out how to make it all work. But anyway, so that's something else I can do. Look through all the inputs and come up with a better library for processing input, because particularly in the early days, that was a huge fraction of the time I spent with just processing input. So anyway, those are my broad thoughts about Advent of Code 2021. This is my last video in the Advent of Code 2021 playlist, as far as I'm planning. And do leave a comment if you have any thoughts on what you think I did well or poorly, or what you found valuable or didn't. And if you have any interest in seeing any other videos, whether for anything else or for Advent of Code next year, please do leave a comment, because that's the only way I know whether anyone cares about these videos at all. So, farewell, people of Earth.